All right, today we're diving into something truly cosmic. We're talking about structures in the universe that are so unbelievably huge, they just shouldn't be there. And the fact that they are there, well, it might mean our entire understanding of the universe is fundamentally wrong. Let's get into it.
It's kind of funny to think about, but a fundamental idea in cosmology is that if you zoom out far, far enough, the universe should actually be pretty boring. Just the smooth, even, predictable fabric of stuff with no big surprises.
But what if that's just not true? What if that smooth, predictable picture is completely wrong? And what if, hiding out there in the cosmos, there are structures so massive they just shatter all the rules we thought we knew?
To really get why these discoveries are so earth-shattering, we have to talk about the biggest rule in the entire cosmic playbook, the cosmological principle. This thing has been a cornerstone of our thinking for nearly 100 years. So what does that even mean? Well, it boils down to two big ideas. First, the universe is homogeneous. Basically, the density of stuff is the same everywhere. There are no special places. And second, it's isotropic, which means it looks the same no matter what direction you're facing. It's like being in a thick, even fog. There are no weird clumps or clear patches. Now, of course, when we look around our little corner of the universe, we don't see that at all, right? We see this incredible cosmic web with these huge filaments of galaxies, giant clusters, and these massive empty spaces called voids. The cosmological principle says, yeah, that's fine. But it also says that if you just zoom out far enough, all that structure should just average out and disappear into a smooth background. The big question, though, is how far is far enough? Well, physicists actually did the math and came up with a number. They figured the universe should look smooth on scales larger than about 370 megaparsecs. That's a mind-boggling 1.2 billion light-years across. So according to our best theories, you simply should not find a single connected structure bigger than that. Remember that number, 370 megaparsecs. It's like the cosmic size limit. Okay, so we've got our cosmic size limit. Now let's talk about the discoveries that have just blown right past it. Because astronomers are now finding things that for all intents and purposes have absolutely no right to exist.
So let's meet a few of these heavy hitters. You have the Shapley supercluster. It's huge, no doubt, but at 90 megaparsecs, it's playing by the rules. But then you have these two new discoveries. There's Quipu, this massive string of galaxies that clocks in at an incredible 428 megaparsecs. And then there's the Big Ring, another type of enormous structure, measuring about 400 megaparsecs. Both are way, way over that 370 megaparsec legal limit. And that name, Quipu, it's actually really cool. It comes from this ancient system of knotted cords that the Inca Empire used to keep records. It's just the perfect name for this long, tangled filament of galaxies stretching across the cosmos. You know, the statistical chance of finding even one of these things is astronomically low. But check out this quote from Alexia Lopez, one of the researchers. She points out that we haven't just found one, we've found two of them, the Big Ring and another one called the Giant Arc, and they're practically cosmological neighbors. That's not just breaking the rules anymore, that's making you wonder if you're even reading the right rulebook. So you might be wondering if these things are billions of light years away and spread out over these insane distances. How on earth did we even find them? Well, it took some seriously clever cosmic detective work. It really came down to two different brilliant techniques. For Quipu, they used X-ray telescopes to map out thousands of galaxy clusters. For the Big Ring, they did something else entirely. They used super bright, distant objects called quasars as cosmic flashlights. By watching where the light from these quasars got absorbed by clouds of magnesium gas, they could trace a map of where all the matter was. In both cases, computers then connected the dots and revealed that these weren't just random points. They were part of these absolutely gigantic, coherent structures. Okay, so we know how we found them. But the really big question is, what does it all mean? This is where it gets serious. These aren't just cosmic oddities to put in a textbook. They represent a fundamental physical challenge to the standard model of cosmology, which is the theory that explains pretty much everything we know about how the universe began and how it's evolved. These giants create three massive problems. First, and most obviously, their sheer size just seems to flat out violate the cosmological principle. Second, their incredible gravity can actually pull on space-time, which could mess with our measurements of how fast the universe is expanding. That's the Hubble constant, one of the most important numbers in all of physics. And third, they can even leave a faint imprint, like a hot or cold spot, on the cosmic microwave background, which is our baby picture of the entire universe. So if the old rules seem to be breaking down, scientists are now forced to ask a huge question. What's next? And this is where we have to venture into some really wild, fascinating theories that go way beyond our standard models.
There are a couple of really exotic ideas on the table. One is the idea of cosmic strings. These are hypothetical cracks or defects in spacetime itself, leftovers from the Big Bang that could have acted like seeds for these giant filaments to grow on. Then there's an even more mind-bending theory from the legendary Sir Roger Penrose called conformal cyclic cosmology. This idea suggests our universe is just one in an endless cycle of births and deaths, and that structures like the Big Ring could actually be echoes or ghosts from the universe that existed before ours.
And that leaves us with the ultimate question. Are these giant structures just statistical flukes, incredibly rare exceptions that prove the rule? Or are we staring at the very first cracks in the foundation of modern cosmology? Hints of a universe that's far stranger, far more complex than we ever dared to imagine. Right now, we just don't know. But one thing is for sure, the universe just got a whole lot more interesting.